Make sure the screen is visible to you and I'm audible. Hello, Varalakshmi. So is the screen visible to you all? And I'm audible to you, everyone? I have launched a poll. Please participate in that poll and let me know. Okay. Only one student has participated. Varalakshmi. Okay. Admin, what about you? So let's just start the class. So hi, good evening, everyone. I welcome you all in this session of rigid body dynamics. Okay, this is the question discussion session. Okay, na? What is that? It's a Q&D. Question discussion session. Okay. So we will be solving some of the question of rigid body dynamics, that the chapter that we have recently covered. Okay. So let's just get started with it. The very first question on your screen. I'll give some time to you also so that you can solve it by your own and let me know what is the answer. Okay. So very first question is the moment of inertia of a rigid body about an axis does not depend on its mass, does not depend on its shape, and does depends on the position of axis of rotation and does not depend on its size. Tell me in the answer. Tell me the answer. Option A, option B, option C, or option D? I'm giving you 1 minute to solve this question. So here, if you recall the formula of moment of inertia, it is nothing but m into r square. M into r square. And specifically, when we talk about, let's say this is the axis, y axis and x axis. So if the particle is present, let's say m1, m2, m3. So R1, R2, R3 is the distance from the axis of rotation, which means we are measuring this R from the axis of rotation. It means the axis dependency on the position of axis of rotation is also necessary, which means we cannot say this. It depends on the position of axis of rotation. From the expression itself, we can see it depends on the mass of the body. So, does not depend on its mass. ये तो incorrect हो गया. So, and we have to find the correct option. ठीक है. Shape पे भी depend करता है. Because if a disk is rectangular and a disk is circular, so both have different kind of moment of inertia about its axis of rotation. ठीक है. So, ये भी गलत हो गया कि शेप पे नहीं करती. ठीक है, यानी कि ये सही है, बट अकॉर्डिंग टू दिस क्वेश्चन दिस इज नॉट आवर आंसर. डिपेंड्स ऑन द पोजीशन ऑफ एक्सिस ऑफ रोटेशन. यस, सही है. डज नॉट डिपेंड ऑन इट्स साइज. ये साइज पे तो डिपेंड करता ही नहीं. अगर आप डिस्क छोटी लेते हो चाहे बड़ी भी लेते हो, मोमेंट ऑफ इनर्शिया इज ऑलवेज 1/2 mr². क्लियर है. सो ऑप्शन डी इज द करेक्ट आंसर. मोमेंट ऑफ इनर्शिया डज नॉट डिपेंड ऑन इट्स साइज. ठीक है. ट्राई टू सॉल्व दिस क्वेश्चन. हेलो अभिषेक, हाउ आर यू? Try to solve this question. I'm giving you 1 minute. A wheel starting from rest gain an angular velocity of 10 radian per second after uniformly accelerated for 5 seconds. The total length through which it has turned. The total length through which it has turned. ठीक है. Angular velocity is given to you. Omega 10 radian per second. Time taken to change this velocity is also given 5. Starting from rest, which means omega initially is nothing but 0. So from here alpha we can calculate delta omega by delta t. Delta omega is omega final minus omega initial. So it is 10 minus 0 divided by 5, which comes out to be 2 radian per meter per second square. This is the angular acceleration. Now what we have to calculate? We have to calculate the length, total angle through which it has turned. ठीक है. Total angle through which it has turned. एंगल के लिए क्या? लेट मी सी अभिषेक, आर करेक्ट और नॉट. सो एंगल को कैसे कैलकुलेट करेंगे? ओमेगा भी है. ठीक है. डायरेक्टली ये फॉर्मूला भी लगा सकते हो. ओमेगा नॉट इंटू टी 1/2 टाइम्स अल्फा टी स्क्वायर. ठीक है. दिस इज 0 इनिशियल वेलोसिटी एंड दिस इज थीटा. थीटा इज इक्वल्स टू 1/2 टाइम्स अल्फा. अल्फा इज 2. टी स्क्वायर विल बी 25. So theta here is coming out as 25 radian. Very good, Abhishek. You are absolutely correct. Keep it up. Option A is the correct. Now, this one. Try to solve this one. The moment of inertia of a rigid body about an axis. अच्छा, ये same repeat हो गया ना? और option D is the correct answer. चलो, try to solve this one. The moment of inertia of a thin rod about an axis passing through its midpoint and perpendicular to the road is 2400 gram per centimeter square. The length of the road is the length of the 400 gram road is nearly. ठीक है, length of the road is given as nothing, हमें calculate करना. Mass of the road is 400 gram. ठीक है. Now moment of inertia of road is given as 2400 gram per centimeter square. Sorry, gram centimeter square. देखो moment of inertia has same unit, mass has also same unit. So and we need to calculate the length in centimeter. So no need to change the units. Okay. Now you need to understand what is given about the moment of inertia. Let's say this is the rod and it is given as the axis passing through its midpoint. Midpoint से जो axis pass कर रही है इसके about what is the moment of inertia? 2400 gram centimeter square. When an axis passes through the midpoint of road, what is the moment of inertia about that point or about that axis? It is 1 by 12 ml square. Hope you remember. So put it here 1 by 12 ml square 2400 ml square will become 2400 into 12. M is also given as 400. 20 will 20 cancel out. 6 L square will become 72. So L will become what? Square root of 20. ठीक है. अब देखो square root of 72 is near to square root of 64. 64 से कुछ ज्यादा है and square root of 64 is 8. This is the method to calculate the answer rapidly. Okay, because each and every option is very different from each other. So we can use this method. So this root 72 is near to root 64, which means whatever the square root of it will be greater than 8, but not equals to 9, because 9 ka square root will be 81 and this quantity is less than 81 but greater than 60. So the square root of this number is lying between 8 to 9. And here only 8.5 centimeter is given. So option A is the correct answer. Clear? Any kind of doubt? If anyone has any kind of doubt, you can ask. Okay. देखो लेटेस्ट क्वेश्चन है नीट 2024 से. ठीक है. A bob is drilled in a horizontal plane by means of a string with an initial speed of omega rpm. Okay. The tension in the string is T if speed becomes 2 omega while keeping the radius same radius, the tension in the string will become. बताओ. Try to answer this question. I am giving you 1 minute to solve this question. Try to solve it. Everything is given in the question. You just need to calculate it. Okay, any guesses, guys? No? Sure. Let's say the rod is like this. A bob is drilled ना ऐसे rotate कर, ठीक है, circularly, and the tension is acting towards the center. Clear? So tension is acting as a centripetal force. So we can say T is nothing but mr omega square, where r is the radius of the circle, and radius is nothing but, let's say the length of the rod is L. So it will become ml omega square initial. But finally, we have changed the omega ml to omega square while keeping the radius same. So L and L will same. So what with the value of T dash now? ml 4 omega square. So it will become T dash is equals to 4 times of ml omega square, which is T initial. So the tension would be 4 times. ठीक है, ज्यादा स्पीड से घुमाना शुरू कर दोगे तो टेंशन इन द स्ट्रिंग विल इंक्रीज. ठीक है. If anyone has any kind of doubt in the previous question, you can ask. The radius of gyration of a solid sphere of mass 5 kg about xy axis is 5 meter as shown in figure. The radius of the sphere is 5x upon root 7 meter, then the value of x is. देखो, we know the formula of radius of gyration. What the mistake we will do? Radius of gyration is nothing but square root of I by m. ठीक है. We know the value of k is 5 square root I upon m. So it will become 25 m equals to I. Now what? How to calculate this I? ठीक है. तो जिस एक्सिस के अबाउट रेडियस ऑफ जिरेशन गिवन है, उसी एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया यू नीड टू कैलकुलेट. सो वी कैन डू दिस बाय parallel axis theorem. This is the I of center of mass. The distance is also given to you. So I will become here I center of mass plus m into r square. Okay. I center of mass of this solid sphere is nothing but 2 by 3 times of mr square. 2 by 3 or 3 by 8. I think for solid sphere it will be 3 by 8. Or let me just check, is it? Just give me a moment. I'll check it. I'll let you know. Sorry, it is 2 by 5 mr square. I'm always being confused in this. So sorry for that. So it is 2 by 5. 3 by 8 is for 3 by 8 is for hemisphere, solid hemisphere. So it is 2 by 5 mr square plus m into r square. Now you can have it 2 by 5 mr square plus mr square will become 7 mr square upon 5 is equals to 25 m. M and m will cancel out. So this will become, and this is 5x upon root 7. And the radius from here will be coming as, what is the value of r square is coming? R square will be coming as 25 into 5 divided by 7. So r will be coming as root 125 divided by root 7. So it is 5 into root 5 divided by root 7. Root 7 cancel out. 5 and 5 will cancel out. So value of x will become root 5 in this question. Root 5 is given in the option. Yeah, so option D is the correct answer. So this will be the correct answer of it. If anyone has any kind of doubt, you can ask. We are not asking any doubt, so I am considering that you know the questions, you know the answers. So is it so? That's very good for you. But in case if you have any doubt, do not hesitate to ask. Okay. Sure. Now let's just talk about this question. This is from JEE Main 2024. A hollow sphere is rolling on a plane surface, rolling, okay, about its axis of symmetry. The ratio of rotational kinetic energy to the total kinetic energy is x by 5. The value of x is that we have to calculate. Okay. So we know that in in rotational motion, kinetic energy of rotational is given by 1 by 2 times I omega square, which means we need to calculate I and we have to know about omega. But since it is rolling, so we can say that V is nothing but R omega. Okay. So omega ko we can replace by V into R. Why are doing this? I'll just let you know. In translational motion, kinetic energy is given by K of translation is 1 by 2 times mv center of mass square. Okay. Because if this is the sphere which is rolling on this surface, so its center of mass is moving in this way. So that is why it has some certain velocity of center of mass, and it is also rotating about its symmetry, axis of symmetry. Axis of symmetry is nothing but this. It has omega. Okay. So moment of inertia about axis of symmetry is nothing but 2 by 5 mr square. But this is hollow sphere. So for hollow sphere, what is the moment of inertia? बताओ भाई, for hollow sphere, what is the moment of inertia? It's 2 by 3 m into r square. ठीक है, 2 by 3 m into r square. Let's say the radius is capital R. ठीक है. So here kinetic energy rotational will become 1 by 2 times 2 by 3 m r square into omega square की वैल्यू v square by r square. Now you will understand why we are putting omega as v upon r. So this r square will cancel out. So kr here would be 2 by 6 mv square. And this v is nothing but velocity of center. And k translational we have 1 by 2 mv square only. Okay. So total kinetic energy will become k translational plus k rotational. So 2 by 6 mv square plus 1 by 2 mv square. Mv square you can take common, and 2 by 3 also 2 by yes, that 2 by 2, it's 2 by 6 is nothing but 1 by 3 we can write directly. Good. 1 by 3 plus 1 by 2, which is nothing but 5 by 6. 5 by 6 mv square. This is the total kinetic energy. And we have to take the ratio of total kinetic energy with rotational kinetic energy. So kT upon kr we need to calculate. KT is 5 by 6 mv square divided by kr is 1 by 3 mv square. This and this will cancel out. This 2 V square will cancel out. So KT by KR. Okay. KT by KR we have calculated as 5 by 2. But in the question it is ratio of rotational to total, which means KR by KT is given as x upon 5 and KR by KT will become 2 upon 5. So x here is nothing but the value of x in this question will be 2. I hope you understand this question. Any kind of doubt? कौशल्या अभिषेक त्रिशा नहीं. चलो फिर मूव करते हैं नेक्स्ट क्वेश्चन पे. दिस वन. Four particle each of mass 1 kg. Four particles each of mass 1 kg are placed at four corners of a square of side 2 meter. Moment of inertia of system about an axis perpendicular to its plane and passing through one of its vertex is. Okay, so we have to calculate moment of inertia about this axis. Okay, so let me analyze this question here. This is the square that we have, and about this axis we need to calculate the moment of inertia about this axis. Each particle has mass m. Mass is also given as 1 kg. So initially we will consider it as m. Then later on we will put it into the value. Okay, this question you are asking. Look, this is the question. Note it down, Abhishek, and let me know when you have noted down. Okay, clear. चलो सोल्व करते हैं इस क्वेश्चन को. तो ये हमारा एक स्क्वायर है ऑफ साइड एल. एल मीटर में कंसिडर कर रहा हूँ. आई विल पुट द ऑल द वैल्यूज लेटर. ठीक है. सो वी नो दैट in the calculation of moment of inertia, moment of inertia is nothing but m into r square. This r need to be taken as perpendicular distance from axis of rotation. ठीक है. देखो इस पार्टिकल के लिए पार्टिकल नंबर 1, पार्टिकल नंबर 2, पार्टिकल नंबर 3. फॉर पार्टिकल नंबर 1, what is the perpendicular distance from the axis of rotation? It is this length only, L. For particle 3, what is the perpendicular distance? This is the perpendicular distance. Both are at right angle to this. This is right angle. This is also right angle. But what about this particle? What is the perpendicular distance from the axis of rotation? So this diagonal would be the perpendicular distance of this particle. Okay. Now, if this length is L, this length will also be L. So the diagonal will be root 2 times of L. Clear? So moment of inertia of this system will be m1 r1 square plus m2 r2 square plus m3 r3 square. 3 particle, 3 terms. Okay. m1 is what? M. r1 is L square. m2 is M. r2 is root 2L. So it is root 2 times L square. Plus m3 is M. r3 is L square. m3 ml square. So it is 2 ml square plus 2 ml square. ml square plus ml square will become 2 ml square. Square root of 2 will become 2. So it is coming out to be as 4 ml square. Now you can put the value here. 4 into 1 kg into 1 meter. L is given as 2 meter. ठीक है ना? Side is 2 meter. So 2 square. So it is coming out to be 2 to the 4, 4 for the 16 kilogram meter square. H, it would be 16. Okay. So one of the vertex के about, the answer will be 16 kilogram meter square. Clear है सभी को? Everyone? Any kind of doubt in this? No. ठीक है. चलो एक क्वेश्चन और करते हैं. मैं अपने एंड से आपको क्वेश्चन देता हूँ. Suppose this is a disk. Just give me 1 minute, guys. So I'm audible to you. Okay. Chalo, let's just get started with it. What I have tell you. What I'm telling you is this is a disk which is rotating with an angular speed omega. Okay, clear? But what the heck here is, if you see the disk at the top view, you will see a groove in that disk. There is a groove or space in that disk. Okay. In this groove, we have situated a particle. We have placed a particle in between this groove. Okay. So let's say the radius of the disk is capital R. Clear? Now this particle is at axis of rotation initially at this point, and when the disk rotate, it will move into this direction. So how much time it will take to cover this distance? Okay, that we need to calculate. What? So first of all, this disk is moving. So this disk is moving, so this is the non-inertial frame. Although we can solve this question by inertial frame only, but it will be a tough question. To use the non-inertial frame is advisable in this types of question. So we situate ourselves into this particular disk and then we see the motion. So for us, if we are sitting on the disk will be at rest for us. So we can observe the particle. Now, particle is having a straight line motion like this. And which force will apply? So there is no friction in this disk. Mu is 0. So centrifugal force will act into the opposite way. Okay. This is the pseudo force of central motion, centrifugal force, and which is nothing but mv square upon r. Okay. So we can say that F is equals to ma. A radial direction में this force will act. So F will be mv square upon r is equals to mass of the bead particle, acceleration of the bead particle. This m and m will cancel out. So acceleration from here will become v square upon r. Now, since this acceleration is constant, because v is constant, r is constant, so we can calculate the time as v is equals to u plus at. ठीक है? Sorry. For that, we need to know the final velocity. So we will apply s is equals to ut plus 1 by 2 a into t square. S is nothing but r. This length is of r, radius of the disk. U initially it is 0, starting from rest. 1 by 2 times acceleration is v square upon r into t. So t here will become 2r square over v square, which is nothing but square root of 2 r by v. ठीक है? देखो omega is also given, so we can say v is equals to r omega, capital R omega. Omega is equals to v upon r, and here we have r upon v. So time period where will become root 2 upon omega. Got it? Clear hai? Any kind of doubt in this, guys? Able to understand it? What I'm doing? So देखो, initially the disk is rotating. So there is a non-inertial frame because centripetal force of acceleration is centripetal force is acting in this. So whenever the force is acting, there is an acceleration. And when a frame is accelerated, that frame is termed as non-inertial frame of reference. Newton's laws does not hold good on non-inertial frame, we know that. So we situate ourselves, we place ourselves into the non-inertial frame so that the frame would come into the rest for us, and there is an extra pseudo force that we need to apply the particle of the observation. Okay, that we are observing. Clear? So that is why this particle experience a mv square upon r, which is a centrifugal force. Clear? चलो एक और अच्छा क्वेश्चन करते हैं. With this application of centrifugal force, suppose there is a table. I'm showing you the edge view of it. This is table. Okay. And this table is rotating about this clamp. This is a clamp, and this table is rotating about this clamp into this way with an omega, angular speed omega. Okay. A groove on this table is made. Table ka vertical view or top view is like this. So there is a groove on the table like this of length L at an angle theta. And a particle is initially at this point. Let me change the color. Particle is initially at this point. Okay. So we have to calculate if this rotating with an angular speed omega, we have to calculate how much time this particle will take to cover this length small l. So uske liye again, we will situate ourselves in the rotating frame. This is R and this is L. So this situation will be like this. This is R, radius R, and this is length L. Okay. So we know that centrifugal force will act into this particle only. Okay. When it reaches to this point. Clear? So initially when we say it is centrifugal force will act mv square upon r. R is the radius. This. Okay. And how much distance it has to cover? L. But this distance is not in the actual form. So we need to resolve it into two components, which is L cos theta and L sin theta. So ultimately particle has to reach this distance as this. So whenever the particle reach at this point, it must have covered L cos theta into horizontal direction. And this acceleration is acting in a horizontal direction. Okay. This force is also acting in the horizontal direction. That is why it is pushing it up. Okay. So again, F is equals to MAR. F is equals to MV square upon R into M into AR. Okay. M and M will cancel out. Acceleration here again will V square upon R. Now, we can say that again the formula, which is S is equals to UT plus 1 by 2 AT square. UT is 0. Initially, is it at rest? S here is very important. S we are applying in the x-axis, so it will be L cos theta is equals to 1 by 2 times V square upon R. Okay. Now, अच्छा यहाँ पे एक point is one point is also very important. This V having a direction in this way. V is a tangential velocity. Okay. Clear? So we need to say this as the length because particle having direction as vertical velocity direction. So it will be L sin theta here that it need to cover with a velocity v in time t square. So again, it will be 2RL sin theta upon v square t square. T will become square root of 2RL sin theta upon v square. Clear? So this is it for today. I hope that you have enjoyed this session. If anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. I'm sharing you a form with you guys. Just fill out that poll and answer each and every question in the poll and just you can leave the class. This is for marking your attendance. Okay. So please fill it up. Okay. And if anyone has any kind of doubt, you can ask. Thank you so much, guys.